This is Precalculus chapter 12, lesson 2 on page 795. So now we are going to do the same thing that we just did in lesson 1. However, we're going to do it without using matrices. We're going to do it using algebra, and we are going to use our calculators. We'll teach you both ways, all right? So I already taught you how to do number 1. But I didn't use this word. Look at example 1. X plus 2y plus 3z is negative 2. 2y minus 5z is 6. And 3x plus 3y plus 10z is negative 2. So if I were to ask you to write the matrix for this, the term that is used in your textbook is augmented matrix. It means the same thing. If I were to tell you to write the matrix, then you would write, what would you write here? 1,
2,
yes,
3,
yeah,
negative 2,
yep,
0,
0, 2,
negative 5,
yes,
6,
yes,
3,
yep,
3,
mm-hmm.
10, and negative 2.
And this hyphenated line is to indicate that you're actually putting the solutions with it. Okay? But if I am naming this matrix in terms of its dimensions, what are the dimensions of this matrix? Yes, it's a 3 by 4. Rows by columns. Let's lock that in our brains. Rows by columns. Rows by columns. Okay? That's all example 1 is, writing the augmented matrix. How can we use augmented matrices to solve equations? Okay, everybody look. If it were consistent at one point, everybody really needs to pay attention here. If it were consistent at one, okay, remind me, when I'm using algebra, how do I know it's inconsistent?
It's illogical.
It's illogical. 5 doesn't equal, something like that, right? That's inconsistent. How did I know it was consistent?
Each variable has a solution.
So X had a number, Y had a number, or 0 equals 0. Okay, this is how you know it using algebra. All right, I'm going to show you how you know it using a matrix. All right, so really these first 3 columns represent your variables. You want these first 3 columns in what's called reduced row echelon form. It's called reduced row echelon form. All that means is my diagonals, this diagonal, all of these numbers, I want to be 1s. Everything above it, I want it to be 0s. Everything below it, I want to be 0s. All right, so I'm just going to make up this in reduced row echelon form. It will be 1, 0, 0, and maybe a number. I'm just going to make up numbers, okay? It'd be 0, 1, 0, and a number, 0, 0, 1, and a number. This is reduced row echelon form. Your diagonals are 1, everything above it is 0, everything below it is 0. So this first column represents what variable? X. The second column, the third column, and this represents what's on the other side of the equal sign. Yes?
How did you get 2, 3?
I made it up.
Okay.
I completely made this up. Okay? This would be consistent at one unique point. Okay, everybody look. X is equal to 2. Y equals 3. And Z equals 4.
It's just depending on the row, right?
Right.
So X, Y, Z.
X, Y, Z. This is consistent at one point. What do you think this would be? Can all these zeros equal 4? So what do you think this is? This is inconsistent. No solutions in common. This would be inconsistent. They have no solutions in common. Infinite solutions would be this. Got it? An infinite number of solutions. You'd have all of these zeros. Yes.
Could it be the same for the first or the second row? Like the first row equals 0?
Most of the time it's your last one.
Okay.
I can't even think of a time when it's not. What could be different about this one is you could have maybe this. This still means infinite numbers of solutions. So you don't have the diagonals of the 1.
How can there be a 2?
Well, this would be x plus 2z equals 2. And this would be y equals 3. And so because of this, there are lots of solutions that x and z have in common, which that means a lot of solutions. All right, now let's work example 2. So we're going to solve and try to get it to reduced row echelon form. What's reduced row echelon form?
The row is 1.
Diagonals are 1. Everything above it is 0, below it. Okay. So let's write this system of equations in example 2. Let's go ahead and write the matrix. All right, so it's 1, 2, negative 2. This is 2, 6, 2.
Close friends.
Close, thank you.
And done.
And the dot. Dotted line. All right. So we want to get a 1 here, and a 1 here, and zeros here. So I already have a 1 here. So I could make this 0 if I multiply the first row by negative 2 and add it to the second row. Right? If I take negative 2 times row 1 and add it to row 2, that makes this a 0. Doesn't it? Because that makes it a negative 2. And when I add it here, no, it's going to make it a negative 2. Negative 2 plus 2 is?
No, I'm thinking about the other. No.
We're not worried about anything else.
If you have,
You want to work on this first
okay.
column.
Yeah, that would work.
All right, so you work on the first column first. I'm not doing anything to the first row. I'm only working on the second row. I don't change the value of the equality as long as I do the same thing to every term. All right, so I'm multiplying negative 2. So negative 2 plus 2 is, so I'm multiplying negative 2, that's negative 4 plus 6, 2. Then I'm multiplying negative 2, which is 4 plus 2 is 6. Okay, so this is good.
Where did you get 4 again?
Look, I'm taking row 1, multiplying by negative 2. So 2 times negative 2,
Negative 4, yeah.
what's negative 2 times negative 2?
4.
4 plus 2 6.
So 6 times -2, -8.
No, no, no.
No,
The
I'm
first
thinking-
row times -2. 2 times -2. -4 plus 6.
2. Oh, okay.
You see, I wrote down what I was doing.
Yeah.
I'm not changing the first row. Okay, I'm not changing the first row. You know what I just did? I eliminated x in the second row. That's what I did. Okay, what do I want this to be? How am I going to make this 0?
Multiply
Just bottom 1/2.
0.
No, 1/2. What do we?
Okay, but do I want to change this one?
No.
I don't want to change this. I want to leave that one there.
So row 2 times negative. I said times.
Yes, yes. Row 2 times -1, because that's going to make it a -2, and I add it, but is that going to change the first one? No. So I'm going to take row 2,
Okay.
row 2 times -1, I'm going to add it to row 1.
Yeah.
I'm not doing anything to row 2. Not doing anything to row 2. All right, so 0 times -1. 0 plus 1. That's what I don't want to change. That's why you make this 0 first. Everything in this first column you deal with first. Then you go to the second column. All right? Now, -1 times 2. -2 plus 2. All right? -1 times 6. -6 and -2. -6 and -2.
Wait, sorry, what did you say?
-6 plus -2.
Oh,
I heard negative.
sorry. I heard. Yeah.
It's -8. Okay. I'm almost there. What do I need to do?
Get a 1.
Get a 1.
How can I get a 1 here?
Divide by
Divide
2.
by 2.
Divide every term in row 2 by 2.
'Cause it's
That's what I'm going to do. I'm going to take row 2 and divide it by 2.
Technically 2y equals 6.
So it's 1, 0, -8, 0, 1, 3. Okay, what's the answer?
X equals 8. Y equals 3.
X equals -8,
Yeah.
Y equals 3. Consistent
Yes.
at one point. Consistent at one point. Okay, let's do example 3. All right, can you already tell me what example 3A is? Infinite numbers of solutions, because that bottom row is 0.
So it's not inconsistent.
It's not. It's consistent
Oh,
at.
C is inconsistent.
Oh, C is
Sorry,
inconsistent.
I was looking at C.
And what is B?
B is
Consistent.
yeah.
At 1 point.
3 -7.
Okay. All right, let's do example 4. What are we doing? It's called reduced row echelon. And the method that we're using is Gauss-Jordan.
I don't know who Jordan is because I was looking at Gauss Jordan and can't find anything.
I think he's German. Gauss-Jordan. Seems like he's German.
Well, no, the guy's name is Gauss, but there's another guy named Jordan. But I don't know who Jordan is.
Yeah. Okay, yes.
Right above that example.
Does it tell you?
No, I just have a question. Right above
Okay.
example 3, it says any column containing a leading 1 has zeros as all other entries. But earlier when you were explaining it, you had a 2.
Appears to the right of leading ones. Each leading one appears to the right of leading ones in any preceding row. So an example, what? Oh, when I had a 2.
Yes.
That's because there were infinitely many solutions.
Wait, can you pass 0.5?
Reduced row echelon form is the diagonal.
Oh, so it's just no longer that form, but it doesn't mean it's.
Correct.
Okay.
reduced row echelon form, this is the goal.
Okay.
You may not get here,
But other things still tell us.
but it still informs, yes.
Could we do example 4, problem A, but without a calculator?
We are gonna do it without a calculator. So we get to, let's understand the terminology. Gauss-Jordan is all that multiplying that we're doing, right? That's what he came up with. How you could multiply or add rows to get to reduced row echelon form. All right, so we're gonna do this A both ways. We're gonna do it manually or algebraically, and then we're gonna do it in our calculators. All right, what do I wanna do first?
Get one in the next one.
I wanna get 1 here, so how can I get 1 here?
Divide by 2.
Divide by 2, yes. So I'm gonna take row 1 divided by 2. So I end up with 1, 1/2, 0.
Yes.
Okay. Now I want a 0 here.
You add 4.
I want a 0.
Yeah.
Yeah.
Multiply the top one by 4.
I have to multiply the top one by 4 and add it to the second one.
Why the top?
Because if I multiply 1 by -4 and add it,
Only other one.
you can't add values to each term. Okay, why can I not add values to each term? Because it changes the value. Okay, look. Look, that's what really what matrices represent, right? Our equations. What if I said I'm going to add 2 to each one of these?
Doesn't really work.
It doesn't.
There's no-
It's not algebra. It's not the rules of algebra. They do not equal.
But you could multiply.
But I can multiply. That is correct. All right. And then I can add my x's, I can add my y's, I can add my constants. Okay? So I'm going to multiply row 1 by 4 and add it to row 2.
So
All right, so row 1 times 4 plus row 2. I'm not doing anything to row 1. That seems to be the hardest when I tutor kids. Parkview does this a lot. When I tutor kids, they can't understand. I'm only dealing with 1 row at a time. All right, so that's -4 plus, that's 4 plus -4 is 0. Okay, so 4 times 1/2, 2 plus 1, 3. Well, that's just 0, so that's 18. All right, I want to make this 0. How do I make this 0?
Divide by 2.
No, because your 1 would change.
I don't want to
Oh.
change 1.
Multiply. No. Yes.
Divide the bottom by 2.
Divide the bottom by
6. Divide the bottom by -6.
and then
Add it to row 1. So I'm going to take row 2 divided by -6 and add it to row 1. Okay, well, I'm not doing anything to this second row. Okay, so that's -1/2 and 1/2, 0. What's 18 divided by -6? -3 plus 0. Okay, what do I need to do now?
divide 18 by 3.
Divide
Bottom one by
the bottom row by 3.
So
I'm going to take row 2 divided by 3. Not doing anything to row 1. So that's,
It's, yeah.
okay, now let's do it in our calculators. All right. Right below math, there's some blue letters that say matrix. You see that? So you're going to hit second x to the -1. Do you see that? Second x to the -1. Yes?
Should I have the same calculator? Oh, I see.
Yeah, second x. Okay, don't move anywhere. So look at the top. You have names, you have math, you have edit, and you should be highlighted on number 1. Are you there? Okay, we're going to edit. So go over to edit, you still should be on 1, and hit enter. And it should say matrix A. What are the dimensions of this matrix? So 2 by 3, input that in. 2, enter, 3, enter.
You don't even have to hit enter, you shut down.
No, you have to.
You have to tell it the measure, unless it's already there. 2 by 3. Okay, you enter a row at a time. So 2, enter. 1, enter. 0, enter. Negative, you should be on the second row. -4, enter. 1, enter. 18, enter. All right, so you've got it entered. All right, so remind me, what is this called? When I get to here, what is this called? Yes.
Reduced row echelon.
Okay, look. Say that again. Reduced row echelon form.
Ref.
R ref. Okay, so do second quit or second mode. So you should just be at your calculator screen, right?
I see it. RREF.
Okay, do second matrix
It's so much easier.
and tab over to math
Yeah, I just did it. So.
and down.
Take number 7.
The RREF.
Yeah, B says RF. Hit enter. And you should be at your calculator screen. It says RF in an open parentheses.
Yeah, your matrix.
You got it? RF. No.
RREF.
RREF.
I got the answer.
Go to math. Go down.
This is so much easier.
There. No. RF. Hit enter. Okay. Don't do anything yet. We're going to go and pop in that matrix. We put matrix A. We put our information in matrix A. So do second matrix. You should be highlighted on 1. Just hit enter. And that should have popped right next to RF. Hit enter again.
Oh, I didn't do it.
You didn't do it right? Well, no, we just did.
Do you have? Are you here?
Go to math. Yeah.
Does everybody have this? Everybody has this.
Yep. It's like
Okay, let's work B. All right. All right, go to second matrix. Let's edit number 2. Okay, so B, for example, 4 is a what by what?
It's a 3 by 4. 3 by 4, sorry.
3 by 4. So put that in as your dimensions and then input your coefficients. After you do that, you always want to go second quit. You want to get out of that. And then go back and do our ref. But you have to quit after you've entered that last number 6. Then do second matrix, math, our ref.
Yeah, why would we do it that way?
And go in and pop in matrix B and hit enter.
That was pretty easy. Yeah.
You got it? What is this system?
I can't read that.
What is this system? Consistent or inconsistent? Consistent. How many points?
1.
1. What's the value of X?
4.
Y.
0.
Z.
Negative.
Okay, let's do number 5. Let's put this matrix in C. All right, number 5 is a what by what?
So 3 by 4.
Yes. and then do our ref on matrix C.
Got it.
It is inconsistent. There are no solutions in common. Do you see that? You always look at the bottom row. It is inconsistent. All right, just look at, let's do example 6. It's a what by what? And we can change matrix D. It's a 3 by
3 by
5.
Wait, yes.
It's a 3 by 5.
Can we reuse the matrix?
You agree?
You can.
Can you what?
You can reuse.
Yes, you can reuse A. You're just going to write over it. Yes. Which one are you doing?
Oh, this is fine.
Okay. All right.
This is what I found too.
Go back to your matrix.
It makes it go up and down.
Wait, what? Where's T?
Okay, look, you have 0, 0, 2. That's 1, 1.
Oh.
You have 0, 0.
Oh, it is.
All right, do you get the solution for number 6?
Yes.
Okay, what is wrong with this system of equations? How many variables do we have?
5. Oh. But they all equal 0.
How many variables do we have?
4.
4 variables. How many equations?
3.
Only 3.
But there's 5 spaces.
The only way that you're going to have one unique solution for a system that has 4 variables is if you have 4 equations. Because we have 3 equations and you end up with, like in that first row, you end up with x plus 5.5 z equals 0. Then they're all equal to 0. It doesn't really matter that they're all equal to 0. You do have sort of a diagonal, but you can't have reduced row because you don't have a 4 by 4.
So when you have a row as
So the only way it would be the only way it would be inconsistent is if that bottom row was 1, 2, 3, 4, something like this. This would be inconsistent if that bottom row looked like this. But because the bottom row looks like this, what does that tell me? The value of W equals 0. This is okay. So there are infinite numbers of solutions because we have at least no illogical fallacies, right? No illogical statements.
Well, what, it's not, it's a 4 by 3.
It's a 3
It's a 3 by 5.
by 5.
by 5. In order to have a unique solution, you'd have to have 4 equations. There's no way you can get a diagonal. You can't get it into reduced row echelon form.
So it's automatically
So it's automatically either infinite or none. That is correct.